What's going on, guys? I had a couple of you ask me to make a video on how to do the retrofitting for Bluetooth into the older radios. There's a couple of things that you'll need when you do this. Obviously, you'll need the radio, Bluetooth module, and the 5-volt regulator to supply power over to this guy. When I install these, I remove the micro USB and the headphone jack. I don't use them, and it just adds extra bulk and things that stick out that can touch other things, and I don't want that to happen. When you prep the 5-volt regulator, you don't have to use this one, but if you do, you have to check the notes, because you do have to either adjust the potentiometer that's on it, or you have to cut the trace going to it and then run a jumper for the 5-volt area. These can run off of anywhere between 3.3 volts or 3.5 volts and 5 volts. There's some radios that you'll be able to get 5 volts inside of. A lot of the older ones won't have that, or if they do, it's more of a like a signal than a steady power, and if you apply any load to it, it's going to bring it down and cause the radio to not work. So on top of all that, you'll need the basic tools and a speaker. Now, I'll make it obvious what the speaker is for in a second. If you have money, swing it for an oscilloscope, you can do that. I prefer the speaker. It makes it easy, and you'll see what that's for. Now, obviously, first thing you want to do is test the radio. I know where this radio came from. I've already tested my vehicle. I know it works. If you don't have a vehicle to test it in, you can look up a pinout for the speakers and just wire it up that way. You'll want to look up the pinout anyway, so you can power it up and give voltages and figure out where everything is. This one I've already worked on a couple of this specific model. This is actually the model that I started all this on. There's a couple of different ways that you can do this. You can feed it into the tape portion of it, which is a very good option, because that way you could just have, cut power going to the motor so you don't hear the tape spinning around, and then you can just give them a dummy tape or a tape with nothing on it to feed into it to play while they want it in Bluetooth mode. Now, it's not always that simple, because a lot of the older radios, they'll start seeking for a track. If they don't see it, they'll click back, and you'll hear this run. Even if it's not the motor, you'll hear like the tape head going in and out. On this model, I found it best to feed it into the radio. So, how do you determine where to feed it in? It really depends on what radio and what model you're using. This one, like I said, I've already done it a couple of times. But what I would do if I didn't know this radio, I would take 5-10 minutes and look up the data sheet for each one of these chips to figure out which one or what each one does and decide the best way to do it. Now, if you can't find data sheets, what you can use is you can use this speaker. You ground it out and you go individually from each pin and just listen for sound. So you hear that? Those obviously aren't audio lines. Now, I'm in a concrete building. There's no antenna attached to this, so even if I were to find the right one, it's not going to make any noise. What I'll do sometimes is I'll get one of those cheap FM transmitters that plug into the cigarette outlet, and I'll power it by the bench power supply, and I'll put it right next to the radio. That way I can get some sort of signal going into it that I can identify. Now, let's see what's next. Like I said, I've already done a couple of these, but what I would do is I'd go through, look each one of these chips up, try to find the data sheet, and for this one, it's the LA3373. Look this one up. It's the FM demodulator. Here's the paper for it, or the data sheet. The main thing that we're looking at on this is these guys right here, R and L. I'm going to go ahead and say that this is the right channel and the left channel. This isn't the surround sound in your house. There's no rear. There's no fucking middle back channel or anything like that. These are very simple old radios. And keep in mind that the older you go on the radio, the less information you're going to find on it. This it doesn't look like it right now, or it might depending on how you look at it, but this is actually hand drawn and then a scan uploaded. This particular pinout's probably been floating around for the last 2.5 decades, 3 decades, and it took some searching for me to find it. But yeah, I know what pins I want on this. Obviously this chip's keyed. You can see the little notch out of it in the front there, and the notch right there. So what I want is not the first pin, not the second pin, but the third and fourth right here. It'll be left and right channel. If you have the FM transmitter, you'd be able to just touch it right there and you'd be able to hear the music going. It wouldn't be super loud, but you definitely know that it's the right chip. So the next thing is, if we just feed power into this guy, but leave, or feed signal into this guy, but leave power going to this guy, there's going to be a lot of interference going on. So again, looking back at this, how can we cut power to it? We can cut VCC right here, which is actually pin 1, top left. The next option that we have is to cut the main ground for it right here. Now, there is going to be additional resistance. There's going to be additional paths to ground within the chip. I'm not too worried about it. I know that this chip won't power properly without that ground. Again, it might take a little bit of trial and error for you guys to figure out the best way to do it, but I know that this works on this particular model. So what I'm going to do is I'm going to go ahead and cut the recording and get it so I have some leads wired onto those guys right there. So I got those leads soldered on. The next thing, oh, I also cut the that ground pin that I was telling you about. So I got the lead soldered on, the ground pin cut. The next thing that we have to decide is, where are we going to get power for the 5-volt regulator? Now you can just power this guy on and start meting around on the inside and figure out where you can get power from. What you'll find is the further in that you go and draw power and ground from, the more interference you're going to have on the signal. I know that this guy right here, this resistor, has 12 volts on it right here, and there's direct continuity to the 12 volt input in the back, but there'll be a lot of popping and buzzing and noise like that going on. And on top of that, these radios, they're set up to have power 24/7. Anytime the battery's in the car, these radios will have power going through it. And this is a always on power. I don't want this Bluetooth module powered up anytime the car's off. So what I do is I would flip it over and I would start metering where the inputs are, the power inputs. So let me, and again, you could just look up a pinout and use visual clues as far as like what pin to use and whatnot. Obviously I have the signal or the key on pin jumped right now, so it'll just turn straight on, but let me show you. So in volts mode, we can just check a couple around here. Nothing there. 9 volts there. 12 volts there. So I'm going to go ahead and say that this is not where I want to pull power from. My power supply is set to 12.6 volts. That's pretty damn close to that. So this is where I'm going to want to draw power from. And then the same thing goes with the ground. You can find a ground on the inside, but if you're sharing grounds with something else or you're tapping into another ground, you're going to have ground loops, and there's going to be a lot of interference going on. There's going to be a lot of hissing, popping, and it's going to get worse when it's put into the car. And then you have the noise from the ECU going in there. You got alternator wire feeding into it. So what I do is I would just solder right here into the chassis ground. I know that the ground for the power has straight continuity to the ground on the power plug. So it's going to be the strongest and the best ground that I can find. So let me get that soldered on real quick, and then I will come back to you guys. Okay, so I got those soldered on there. I went ahead and fed them through this little crevice right here to get them to the other side where everything else is. Now obviously you'll need a place to put the boards, and this little nook right here is where I'm planning on placing everything. Obviously when you're moving this thing around, make sure that the power's not going to it. Next, what we'll want to do is we'll want to start prepping the modules, and we're going to want to think to ourselves, how are we going to turn this guy on and off at will? Now, there's a couple of things I won't tell you in this video, and one of them is how I'm going to keep this guy working, the FM demodulator working, and this working at the same time with no interference. What I can tell you is that there's a switch on the front of this radio that's labeled CR. Now, for the younger people, this is for chromium cassettes. Not a lot of people use them, especially nowadays. They were higher fidelity cassettes that were available back in the day. And I know for a fact that the gentleman that owns this radio is not going to use that button. So I would go ahead and look, and I would see that that button goes here and it goes over here. So I'm going to desolder these guys and use this as a switch for the ground going to this guy. Now, I'm still going to ground up there, but this 5-volt regulator has an enable pin. Let me see if I can, it's probably not going to focus, but there's an enable pin right there. And on this particular board, it's internally tied high. So if this enable is left open, this is on. Now, if you ground that enable pin down, it's going to shut it off. So I'll still use the chassis ground up here for a ground for the power for this, but for enable, I'll use whatever ground is going on over here. I'm going to go ahead and say that the black wire is probably the ground wire. It's going to the biggest plane, but let's do a quick sanity check and just confirm that real quick. There you go. Guess I can do this being recorded real quick and just pull that. What I'm gonna do is just get some solder and flux on there. Yeah, I know I'm melting the wire a little bit. I'm not too worried about that. This is going to end up getting cut a little bit. Really, if you wanted to do it the proper way, you could solder straight to the switch up here. I might do that. We'll see how I feel in a couple of minutes. So, yeah, let me cut and I'll get this guy soldered together. The reason I keep cutting is because the camera is actually on my scope stand right now. I don't have a scope camera. So, every time I stop, it's so I can see what the hell I'm doing. I might micro solder for a living, but my eyesight is not the best. So I'll show you what I do and I'll explain it once I'm done. So just give me a minute, all right? Now, quick side note: the ground, for the ground, there's a couple of different ways that you can do it. What works best for me is the ground for the stereo is a common ground. It uses the same ground for the power and everything, so I just use a little header right here between the two boards. I wrap this in Kapton tape just to make sure that nothing shorts out. There's really nothing on the back side of the module that it can short out against right there, but I'd rather be safe than sorry. So yeah, I just put that guy right there, and obviously it's gonna stay on this way. So again, I'm gonna use that button that's in the front. I'm gonna repurpose that button as on-off switch for this. Just wanted to throw that in there real quick. Okay, so I have it wired up. The positive from the 5-volt regulator going to the key on pin for the power. Grounded to the chassis back there. I have the left and right channel fed hopefully in the correct polarity to the FM demodulator. I'm not too worried about that. If you're doing this for a customer's vehicle, make sure you have that right. If they're going through all this effort, they likely care a little bit about sound quality and having things proper. Most people won't notice if the channels are flipped. Knowing how our shops are, we're going to get the people that do care. So we'll go ahead and power it up real quick and see what's going on. We got a blue light, so that's a good sign. I've already paired this to my computer, so I've confirmed that it works, but it'll just pop up. This particular model shows up as VHM-314, and there's no pin or passcode or anything like that. It'll just pair straight to it and you can start playing music. So what I'll do, just to verify audio quality real quick, and this is how you'd figure out where you can tap in for the signal too. I'll go ahead and touch the pin right there with the speaker and then start playing music. Oops. You can hear it. There's no hisses, no pops, no whines or anything like that. So the grounding and the power is good. Both of them are working right now. So this is receiving a signal. It's got power. It's pairing. Audio quality is pretty decent. And of course, I'm wiring all this in before a preamp. I want to get it as far before that as I can. This particular model, there's actually no amps on the inside of it. It's all external. There's a unit that sits right underneath it that does all the amplification. So coming straight out of here is all low level. So the next thing that I want to do, now that it works, we'll start by turning it off. I want to make it so I can turn it on and off. And again, that enable pin right there, if I ground that out, here, let me just show you. If I ground that pin out, it'll actually turn this guy off. Let me make sure that switch is switched. And then, let's see, right there. See the blue light turn off? And then I can unground it. ground it. Blue light turns off, unground it. Obviously you'd want to not have a lot of power going through a switch or anything like that. That's why this regulator is great. That being said, these don't draw anything for current. I think I checked at 12 volts, it draws like way less than 50 milliamps. You could run one of these modules off like a couple of AA's for a considerable amount of time without any issues. So I'm gonna go ahead and cut one last time, and I'm going to wire into the switch right here. So this has a way to turn on and off. You see I have enough wire that I can very snugly just pack it in over here. Obviously you don't want something just floating around that has metallic pieces on it. If you do a lot of these, you can get some heat shrink that'll fit right over it. It'll look beautiful that way. If you're only doing it for yourself, or you're doing a one-off, or you're only doing a couple of them, you can just wrap the whole thing in Kapton tape. It'll be fine. If you're real concerned, you can put like UV mask or liquid electrical tape over the contacts. It's a car. It's not going to get jostled. Hopefully it's not going to get jostled around a lot. So generally if you put something in one spot, it'll stay there. You're better safe than sorry though. So especially if you're doing it with the customer's device. So insulate it, get it off to the side. Talk to you guys in a moment. Alright, so I did solder it straight to the switch. I wasn't lazy this time, but I got everything soldered up. At this point, all I would have to do is assemble it. Now, when I get in the swing of things, it'll only take me about 30 minutes to do one of these, sometimes less. So, just to show you, there's power going to this guy. It's on. I press that button, this turns on, I press it again, off. So what I would do I don't want to give too much away, especially for this specific model. I doubt you guys are going to run into it, but I could feed that ground right there in with the same wire as the enable pin to the switch. So when I press this, it'll turn this on. When I press it again, it'll ground that wire out and it'll allow this chip to turn on. The only thing is there's enough internal resistance in that chip or there's a lack of internal resistance in that chip. So what'll end up happening, if I can jump it across here, is that FM modulator will end up turning off. It's not doing it right now, but I swear it'll do it. So there's a couple of things that you can do to prevent that, between like pull-up resistors or diodes. There's 1,000 different ways to solve that issue. That's a bit beyond the scope of this set of videos. Maybe if there's enough people that are interested in it, I'll get into that. I doubt we'll be at that point. But yeah, any questions, let me know. I'll do what I can to answer any of them. There's some questions that'll be beyond my scope. Obviously, it depends on what radio you're working on. But I hope you guys use this as a way to bring additional income into your store. It's not consistent money. I get enough that it's worth me doing, but I'm also in specific car clubs that deal with these radios. Now, if you didn't want to feed it into the FM modulator, real quick, I'll just gloss over this. You just put a tape in here, play it, and you'd use the same process with the speaker to figure out where the channels are. You'd have to trick this into thinking it's in tape mode. So you'd put a cassette in and figure out what contacts are the switch for when this actually moves down. So I'd figure out what gets grounded out when it's like that. Again, I know on this specific model which one it is going to be one of the guys back here. But it's super simple to figure all that out. It just takes a little bit of time and a little bit of troubleshooting. But yeah, thank you guys.